Not really? Okay. Okay, Zoom was on the fritz yesterday, so I'm guessing that was it. So if it gives you trouble moving forward, email me. Let me know, and I might have something we can do about that. All right, what's your name, sir? All right. Okay, and I do have 8 o'clock. I feel like, I know we're supposed to be socially distanced and everything, but this still looks like pretty sparse attendance. Part of that might have been me very late. Yeah, we have 21 people in the Zoom, so that's probably it. Okay, so like I told you guys, I think last week as well as yesterday, attendance for this class in person is optional, but you need to show up in some form. See, we have 20 people in the Zoom, so I'm not really going to worry about it. Sorry about switching up the roster. I did not realize we had as much roster turnover as we did. I looked at the roster I was working with and the actual people that were in the class, and I did not realize how many people had like dropped the class and then different people had added it. So we've had a bit of a shakeup in people in the class. I did not realize how big it was. So I'm sorry for the Monday versus Tuesday group shakeup. I'll try to switch people that want to be switched. Let me know if you want to switch what day you're on, but we'll work it out. Zoom people, hey, y'all got questions? Anybody here got another math question for me? Otherwise, we'll just get right into it. I don't hear a disembodied voice commanding me to do something, so here we go. All right, so today I want to talk about a couple things. I want to review a little bit what we did yesterday, and I want to get into some new stuff. The new stuff's going to be really important moving forward, so I want to make sure y'all have that on board. So it just came in. What's your name? I have a question for you at the end of class. Don't worry, you're not in trouble. Just curiosity thing more than anything else. Okay, so yesterday we talked about something where we factor out the common terms. And that was, I think, relatively straightforward, right? So if you have like, you don't necessarily need to write this. This is kind of a silly example, but if you have 2 cats plus 3 cats, somebody tell me what you have. You have 5 cats. Perfect. But let's write it a different way. I want to say that is 2 plus 3 cats.
Can you share your screen?
God dang, I'm doing it again.
Thanks.
I will get better at this. And share the paint. Bam. Okay. Didn't miss much. Yay. Okay, so if you have 2 cats plus 3 cats, you have 2 plus 3 cats. Okay, so if you have something where you have 2 x's plus 3 x's, clearly we can put them together, that is 5x. Clearly we can do that. We have 2 things plus 3 things, we have 5 things. Yay. But if you have something a bit different, then we have to do something else. If you have 2x squared plus 3x, okay, now things are looking a little bit different. We can factor this, and we can take out, there's an x in common, and I can say this is x times 2x plus 3. If I take an x off of the 2x, we knock that exponent down, we just rip it straight out of the 3x, and we're left with x times 2x plus 3. The other way to think about this, you had 2x x's plus 3 x's, you had 2x plus 3 x's. That's what you had. Think about more like the 2 cats plus 3 cats, and I swear you'll be more successful. Questions about this? This is really basic, but I want to make sure we have this nailed for when we do the fun stuff today. Okay. Oh, the other thing too. I have like a mild notoriety on campus for having like being one of the most prolific snappers. I swear to gosh, I'm not snapping you like you need to pay attention more or something like that. And that's just like something I do. So you've probably heard it. I'm wearing a mic, so they're gonna hear that really loud. But I swear to gosh, that's just something I do. I'm not angry or anything when I do that. Anywho, so yesterday we took out common factors. It was something that was in everything. Now I want to talk about factoring where we don't just have a common term in all three of them, and yet we can still factor it. So I guess the best name I would give this thing is factoring trinomials. Okay, and if you're looking at that word, factoring trinomials, what the heck is a trinomial? It's got three different kinds of terms in it, is all it is. So you have x to some exponent, let's say squared, right? If I have just a good old x, and if I have some kind of number, let's throw in, I don't know, 1. Okay, that is an example of a trinomial. You have three different kinds of terms. You can't put them together anymore. There are no more like terms that you can squish together just with addition. So this is what's referred to as a trinomial. It's not a huge deal. People don't really think about, oh, look, I have a trinomial am I working with? No. We don't really think about it like that, but that is the term we're going to use. Generically, there's a whole family of these things called polynomials. And they are what you think they are. They're just strings of x's and numbers. And they might have different exponents on them, but they're all slapped together with addition. That's a generic term for basically those critters. It's just polynomial. Now, if we have a trinomial, if you were to gaze your eyes on the example x squared plus 7x plus 12. All right, now if you put on the thinking cap that you were wearing yesterday, that thinking cap would tell you, okay, there's nothing in common between all of these. Okay, yeah, these have an x, and 7 and 12, like there's nothing really in common there even. I don't know what we could do with this. And if I tell you though, you can factor this, please factor this for me, you might be scratching your head a little bit if you're trying to use the tools I gave you yesterday. What I want to talk to you today about is something very important. It's called the AC method. All right, and the AC method, how many of you guys in the classroom, show of hands, how many of you heard of the AC method? See a few hands, Spoiler, those of you that are not raising your hand, you still might have seen this before. We just didn't call it the AC method. Very much depends what state you grew up in. They all call it different things. And basically the idea is this x squared, it has a hidden 1 on it, right? 1x squared, that's what it is. Okay, generically we write our trinomials, we can write our trinomials as ax squared plus bx plus c. That is generically how they're written. You have some amounts of x squared, you have a amounts of x squared actually, plus b amounts of x plus c as your constant term. No x involved. So with that, what we're looking for in order to factor this thing is we want to look at what numbers you can multiply to get AC. So AC, in this case, is going to be 1 times 12, so just 12. So we're looking for numbers that multiply to make 12 and add up to be B. That's the magic thing. Numbers that multiply to make AC. So I'm looking for 2 numbers. And so I'm just going to make 2 copies of this. And what I want to be able to do with them is I want to multiply them. Terrible. To get AC, and you want to be able to add them to get B. That is how you're going to be able to factor every single trinomial in my class. Every single one. If you have a if you have an actual trinomial and you do this, you're going to be able to factor it. So what kind of numbers make up 12? So 3 and 4. Okay, so if we try that, so if we do 3 times 4, we get 12. If we do 3 plus 4, we get 7. Hey, that's awesome, because that's our B term too. So that's going to be the combination that actually gets us there. So what do we do with those numbers? We just put them in for our factors. So your factors generically, especially when you have this 1 as coefficient on your x squared term, you're going to end up with x plus 3. That's one of the two numbers we came up with. And then x plus 4. Again, as I said yesterday, if you're not sure about how well you factored something, you can always FOIL it to check your work. It turns out you're always, for this first unit, you're going to be able to go forwards and backwards to not only do your problems, but to check to make sure you got the right answer, if you're not sure. If we went ahead and FOILed this, man, this thing keeps sliding down. Okay. X squared plus 3x plus 4x plus 12. Hey, look at that. 7x. Perfect. Okay, so that works. Those factors are the factors that go with this trinomial. Okay, the AC method, again, just if somebody comes up to you and asks you, what the heck is it? You got a trinomial, you're looking for two numbers, they multiply to make AC, they add to make B. Questions on this process so far? Okay, let's do another one. Oh, the key here, so far, this is really nice, because this is addition and this is addition. When those signs start changing, that's when things get a little bit complicated. So I'm going to make sure you guys know what we're doing the entire way, but I just want you to keep a heads up that signs very much matter on these trinomials. All right, another example. Let's do x squared plus 6x plus 9. All right, looking for two numbers that multiply to make 1 times 9, so just 9, and they add to make 6. Anybody want to volunteer two numbers? Not you. 3 and 3. So 3 and 3 is going to get the job done. So our factors are just going to end up being x plus 3 and x plus 3. And that'll work out. And again, we can check it with foiling. Super quick, super simple. X squared plus 3x plus 3x plus 9. Those two will combine to make our 6x. Perfect. Question? As a matter of fact, you can. You could just write it as x plus 3 squared if you want to. Yep. Good thinking. All right. Let's do one more with addition. Let's see. So x squared plus 8x plus 12. All right. At this point, you guys know the drill. We're looking for two numbers that multiply to make 8 times c. 1 times 12 is just 12. Then they add to make 8. So what are we looking at? 6 and 2 is going to get the job done. Heck yeah. 6 times 2 is 12. 2 plus 6 is 8. So our factors here are going to end up being x plus 6 and x plus 2. All right. Now, I want to spice things up a little bit. But before I do that, I do want to point a generic rule out, and then I'm going to show you how that rule actually works. Oh, if I'm scrolling too fast through the notes, stop me. Like if you were still looking at this example and I just kept scrolling, like yell at me or something. Totally fine with that. But anyways, so I said earlier, when we're looking at trinomials, we have ax squared, we have bx, we have c. Okay. If this thing is a plus on the back end, if you have a plus between bx and c, that means the signs on your factors will be the same. You're going to have some kind of like minus and a minus, or you're going to have something plus something times something plus something. When this thing is a plus, you get the same sign. On the flip side, oh, and then this thing tells you which one it is. So if that front term, if that blue symbol that I just put there, if that's a plus, then they're both going to be plus. And you've seen that. We've been working with that up here. They've both been pluses. You check the back one, you know they're both the same. You check the front one, you know they're both plus for your factors. So that's nice. If this front one, if this was a minus, all right, if I go back and make that a minus, then these would both be minuses instead of pluses. That would be the only thing that changes, actually. So that's something you can take advantage of. Now here's where it gets a little bit trickier. If instead I have ax squared, let's not look at the front one, let's not look at the front sign. If I have minus c, are you having trouble seeing from over there? Okay. If that's a minus back here, gonna make that in red, then they're gonna be different. You're gonna have some version of something x minus and then something x plus. And then if you want to see who which is which, this front symbol tells you which one's bigger. All right, now quickly, as an example of that, if I were to have, let's do x squared minus x minus 12. Okay, if I look at that back term, this is a minus, so I know they're going to be different. Now, this is a 1 out front, so I know it's going to be x minus, and I know it's going to be x plus. Now, AC method, what numbers multiply to make 12? So if you look at 12, you know that's either going to be like 12 and 1, 6 and 2, or 4 and 3. Those are your only options. Now, we're looking at ones where the difference between them, the gap between your two numbers, is only 1. And specifically, we want it to be a negative 1. What's going to do that? Well, 12 and 1, they've got a huge gap between them. That's 11. 6 and 2, they have a gap of 4 between them. 4 and 3 is going to get the job done. They're going to have a 1 gap. Now, which one goes which? I said this one tells you which one's bigger. So that front minus is going to tell us that the 4, the bigger number, is going to be the negative 1. So that's what I'm putting in. So like I said, it's a bit more complicated, but you just need to be very methodical about it. You have your trinomial, you look at the back sign, and that tells you whether they're the same signs on your factors or opposite signs. You look at the front one, and that tells you which one should be bigger. Then you do your AC method, and you start trying out numbers. Totally recommend when you're doing this, make a table like this one. If you make a table like this one, and then especially for those minus ones where you need to find the difference, draw out those differences, and that'll help you tremendously. Okay, I just talked for a lot. I just threw a lot of very technical algebra at you. What questions do you have? At some point, you guys are going to start talking. I swear it'll happen. Correct. So, right. So let's look alternate universe here. If this was x squared plus x, and I didn't change anything else, you're absolutely right. That would simply end up being x plus 4 and x minus 3. Everything else matches up. The only difference is the bigger number ends up having to be a positive. So it ends up having to be the bigger number 4, it has to be x plus 4, and then x minus 3. We're going to do more examples of these, but any more questions right now? Great question, though. Okay. Moving right along, let's take a look at x squared minus 3x minus 10. Okay, this is another one of these tricky ones. This back tells us the signs are going to be different. So I already know I'm going to have some version of x plus something and some version of x minus something. The front sign tells me the bigger number has to be the negative one. I know that already, so this is good. So now let's go ahead, let's make our table. So numbers that multiply to make AC, AC in this case is 1 times 10, so 10. So what makes 10? Well, 10 and 1, 5 and 2. Don't really have many options. So what are the gaps between them? Well, this has a gap of 9 between them. That's not going to do it. This has a gap of 3 between them. So that's how we're going to get that. So this 3 gap matches the 3 that we want on our middle term here. That's our middle coefficient. Yay. We're in the money. The bigger number has to be negative. So if this bigger number has to be negative, I know this 5 has to go right here. So we get x minus 5, x plus 2. And again, if you're ever doubting yourself with this, just go ahead and FOIL it. Just check your work. So we get x squared plus, no, outer, so we're going to get minus 5x plus 2x minus 10. And you can see right away that we get this minus 5x and the plus 2x. That makes our 3x. So we get back to our original answer. Awesome. Okay. Questions about this? See, I have this habit from last semester where I would ask if anybody had questions all the time, purely because I just wanted to give myself the chance to sip down more coffee. Unfortunately, I can't do that this semester, so I should probably lose that habit to some extent. Okay, let's look at maybe a bit of an easier one. So if we have x squared minus 15x plus 56. Okay, back sign is a plus, so I know they're both the same. And since this front sign is a minus, I know they're both going to be minus. So I know I'm going to have some flavor of x minus something times x minus something. So we make our table. And since it's plus, I want the two numbers from our AC to add to make 15. I don't want the gap between them to be 15. I want them to add to be 15. And we get that from the plus as well. So 56, we get 56 times 1. We get 28 times 2. And then somebody's already saying it, so I'm just going to skip straight to it. Yeah, 8 times 7. So those are going to be our two factors there. Now, one thing to note, you can just jump, especially if you have a 1 for an x, you can just jump straight from, oh, these are my numbers, my AC. Oh, perfect. That's what I'm going to plug in. However, if you don't have a 1 in the front, you can't quite do that. The good news is there's another way we can use those two numbers from our AC. Is what we can do is we can actually rewrite our answer here, or not our answer, but our starting trinomial. We can rewrite it using those terms from the AC. And the way we can rewrite it is we can say we have x squared, and then just pick one, minus 8x minus 7x. They both have to be minus. plus 56. So far you're like, okay, but why? And the reason is we have this other technique we can use, and you're going to end up using a lot. It's called factoring by grouping. And when you factor by grouping, what you basically end up doing is you draw an imaginary line through your problem, is what you end up doing. And if you just look at the front half, right, we have x squared minus 8x. So if I just look at that front half, what's in common with both of them? They both have an x. So take it out, and you get x times x minus 8. If you look at the back half, rip the number out. So you get a negative 7 you can rip out of it. And you're left with x plus 56 divided by a negative 7. Won't give you a plus. It'll actually give you a minus 8. And would you look at that? We get the same term out of both of them. That's good news. That means you're doing it right. So you have x amounts of something minus 7 amounts of something. Okay, so going back to the cat problem, you have 2 cats plus 3 cats. You have 2 plus 3 cats. You have x somethings minus 7 somethings. You have x minus 7 amounts of something. And that's the other way to get your answer. Now the key here is you're probably like, well, Andrew, that's way more steps to get the same answer I was getting before. Why on earth would I ever volunteer to do this? And the answer is you're going to face problems where this is going to be the only way to do this. And so let's show you some of those right now. So if I had 2x cubed minus x squared minus 12x plus 6. I ripped this straight from your homework. Didn't get creative with this at all. Just ripped it straight from your homework. So if I tell you factor this by grouping, okay. So go ahead, split it in half, and what do we have? We can rip an x squared out both those first two terms. So let's go ahead and do that. So we get x squared, 2x minus 1. Now rip out a negative 6 from both those back terms. So minus 6, and what's left? 2x minus 1. Now, anytime I have a negative on this third term here while I'm factoring by grouping, anytime I have that, nice. Anytime I have that, always take the negative with you. So if you have this negative right here, always rip it out when you're doing the factoring by grouping. Always, always, always. It will never lead you astray. I can guarantee you that. For the most part. The other key, though, is if you're not sure whether to bring a negative with you or not, just make sure that this term that you have here, this 2x minus 1, you want to make sure it matches. Because this trick only works when those two things match. Right? If I have 2 cats plus 3 cats, I have 2 plus 3 cats. If I have 2 cats plus 3 dogs, I just have a whole bunch of animals that are going to make a mess for me. So you need them to match up in order for the addition to work nicely. In this case, subtraction, but same difference. Okay, so we have x squared amounts of something, minus 6 amounts of something. When we end up factoring this, we can say we have x squared minus 6 amounts of something. And that something is 2x minus 1. Okay, now the good news is there's nothing else we can do at this point. X squared minus 6 is not the difference of 2 perfect squares, like we were looking at yesterday a little bit. So no joy on that. Questions about this question?
What if the 2x to the third was negative? What do you do with a negative number starting?
Sure. If you have a negative number starting, try different things. So is my first answer. Because, so alternate universe. If we had negative 2x cubed minus x squared minus 12x plus 6. Y'all don't need to write this because, spoiler, this won't work. But hypothetically, I would try ripping a negative x squared out of both of them and having 2x plus 1. But then I would also try not doing that. I would actually try x squared and leaving it, having a negative 2x plus 1. So that's my answer, is if you have a negative out front, you're not sure what to do with it, try it both ways and see if you can get a match with this term over here. So, good question though. Anything else? Okay. Yeah, good call. Yeah, good call. Okay. Didn't really care too much about that problem because I already knew it wasn't going to factor, but good call. Just generic practice. All right, let's do another example of factoring by grouping. This is going to be a good one. I can tell you that because I made this one up. Let's say we have, I actually skipped the parentheses there. Let's say we have good old x to the 5th minus x cubed plus x squared minus 1. Okay, I can already tell you, if you try using that toolkit from yesterday, there's not one common thing between all of these other than like a 1. That's it. So you're going to need to factor this by grouping. So if we do that, draw your line down the middle. And we're going to get, what can we take out both an x to the 5th and an x cubed? There's at least 3 x's in both of them, so let's rip that out. So we get x cubed ripped out. 5 minus 3, we're going to be left with an x squared minus, anything divided by itself is just 1, so x squared minus 1. And then there's nothing really in common between x squared and negative 1, so I'm just going to leave it as plus 1 amounts of x squared minus 1. And I know I can do that because these two terms end up matching. I get x squared minus 1 for both of them, so I know this is going to work out. And I know it's going to work out to be x cubed plus 1, x squared minus 1. Questions so far? We're not done yet. Okay. And the reason I say we're not done yet is this is the sum of cubes that we looked at yesterday. And this is the difference between two perfect squares. Okay, so if you get a problem, and this is more, I didn't devise this because I want to be unnecessarily cruel. I devised this to show you how unnecessarily cruel your web design can be. Because your web design has this glorious phrase in all of its factoring problems, or at least a whole bunch of them, and that phrase is factor completely. And that means even if you get through 90% of the problem, if you left a 2 in there, you didn't factor it out of 2 common terms, it'll be like, wrong. So if you just get to this stage and you're like, okay, I'm done, I did the factoring by grouping, yay, I want to press submit, I want to take my points, click $200, pass, go. Wrong. X cubed plus 1, it wants you to break that down. Sum of cubes. If you don't remember that from yesterday, we had a cubed plus b cubed. Remember SOAP with the sum. So same, so we're going to get a plus b. A squared opposite minus ab, always positive, plus b squared. So our a and b, they're just x and 1 in this case. So if we break this thing down, we're going to get x plus 1, x squared, plus x, plus 1. Now for this term here, difference of two perfect squares. If you have something squared minus something squared, we're going to get plus, and we get a minus. So a plus b, a minus b. So that's what we're going to do here. What are a and b? Again, they're just going to be x and 1. So we get x plus 1 and x minus 1. But wait, there's more. We have 2x plus 1 terms in here. So like Billy Mays, there's always more if you pay extra shipping and handling. We need to ship this over with its friend over here. We need to combine those two terms. We need to get x plus 1 squared. So your final answer for this thing, you get x plus 1 quantity squared. We have that x minus 1, and we have x squared plus x plus 1. I do not remember where in your homework this thing lives, but I know it's somewhere in that website. And I'm very keenly aware of one student that I think spent 2 hours solely on this problem, trying to beat it to death and figure out why WebAssign wasn't taking their answer. And that's because of that beautiful phrase, factor completely. And then also make sure it's in simplified form, hence you need to like combine these two things. So I know it's out there, hence why I'm doing it now. It's in your notes now, you're aware of it. So now you're aware of it. Questions about this question? By the way, how's my volume with me wearing the shield today? Am I like blowing out your eardrums yet? So I think this is like a megaphone, basically. I feel like I'm a dog wearing like the collar of shame, the cone of shame, and it just like amplifies everything. I wonder if I get better self-service while wearing this. Probably not. All right. Let's see. It's 35. You know, I got through all my problems that I made for you guys. So I'm going to just do some of your problems. So give me one moment with technology here. All right. And 111. If you have any questions for me right now, math or otherwise, feel free. Did they do Fall Fest yesterday? Was that thing that they did actually? Okay. Couldn't be me, but good for them. Yeah, sure, why not? Oh, that's no good. I want you guys seeing the answers right away. Fire. Yeah, I don't care. You're in college. I always love it when I have freshmen in my class because they're not sure what they can do. Actually, show none. Can I just do that? I just want to blindly do this. Yay. Because it doesn't help your guys' learning experience if we just have the answer on this screen while I do it. It actually helps you guys to see me think about it, I think. I could be wrong. Let's do even ones. Okay, and the beautiful thing about WebAssign is it randomizes the numbers, so you guys don't all have the exact same problems. So I'm going to do problems here off of WebAssign. They might not be exactly the same as you, but they're really darn close. Same method, so still helpful. Okay, so if I'm looking at number 2, and this is from homework, I want to say this is going to be 7. Actually, it says it up there. Yep. Okay. So we've got good old s squared minus 5s plus 6. All right. Who wants to suggest what we can look at first? Because there's 2 things that grab me right away. Actually, 3. First thing I'm noticing, got plus here. So I know they're both going to be the same. And this critter is a minus. So I know they're both going to be minus. So that's nice. So I know I'm going to have some flavor of x minus and x minus. So if you have x minus and you have x minus, then we just need to do AC method with 6 in order to figure out what our two numbers are. And because this is a plus, they have to add to make our 5. So the only factors of 6 that I know of, without getting crazy, is 6 and 1 and 3 and 2. So I think those are our numbers. So we're going to end up with x minus 3 and x minus 2. For those of you scoring at home, try to figure out whether web sign will take it like this, or if it cares whether I do x minus 2 first. I don't know. I think it'll take it either way. If you write x minus 2 and then take that times x minus 3, or if you do it the other way around, don't think it has a preference. Okay. If we look at number 4. Oh, this is a goodie. 6x squared minus 49x minus 45. All right, so we've got this creature here. Is there anything in common with all of them that we can take out right away? That's the first thing you should be thinking about. Is there a common factor right off the bat? A common number we can rip out? No, it doesn't look like there is. That kind of sucks, but we'll make it work. So now, I know this is a minus. Switch color. No, this is a minus. I know this is a minus. So I know they're different, and the bigger number has to be negative. So that's nice. Got that going for us. So I know we're going to end up with some amount of x minus. I know we're going to end up with some amount of x plus. Notice I'm saying some amount of x. Because there's a 6 out front, I don't know if this thing's going to turn into 6x minus something and x plus something, or if it's going to turn into 3x minus and then like 2x plus. So we have a lot of different options of how this can go. Okay, this is where I need to turn on my mental calculator. Just a tad. I'm also going to write this a bit smaller. Actually, I'll just leave it. So AC, we need to take 6 times 45. I can do that in my head, and that's going to turn out to be 270. You guys probably can't do that in your head, so this is why you guys need to have a scientific calculator. I think maybe your graphing calculator is allowed. Don't hold me to that. I have to figure that out. But we're looking for things that go into 270 for our AC. And because this thing is a minus, the gap between my two factors has to be 45. And that's how we're going to break this thing apart and do factoring by grouping. Anytime you have a number that's not 1 out front, you need to do the factor by grouping. You can't just go straight for what the factors are. So 270. 270 and 1. Okay, so far no joy. Let's bust that in half. 135 and 2, still no. Let's see, let's take a 5 out of it. If we take 5 out of this thing, we're going to get 27 and 10. Okay, now we're kind of getting warmer. But that gap's actually too small now, so that's not going to fly. Let's see, let's go back up. 270, let's take a 30 out. So we get 30 and we get 9. Nope, still not going to cut it. Drat. Let's see. Oh, wait. No, that's fine. So this is the general process that we need to go through in order to tackle these critters. And you can see as I'm struggling with like the guessing and checking, you can see this is not a linear process whatsoever. Ooh. That is something I need to consider, isn't it? Yeah, it is. Okay. If I do that real quick, that might work, actually. 6 times, nope. And I'll tell you what, I can already tell you this guy ended up being a 2x and a 3x, which makes things infinitely more complicated. Yeah, I said this is a goodie. I'm starting to regret saying that. Oh, and that is a plus. I should learn how to read. It's a good skill to have when you're in college. 49. Well, Oh, you know what? Nope, still too big. So if I take all of these problems, or if I take, they are problems, but if I take all these numbers, there we go, multiply this times 2, multiply this by 3. Check the gap between them. Okay, 540 and 3. Okay, obviously too large. Obviously, this thing is not going to help us. This thing also is not going to help us. There's no way I can multiply 2 by anything to make the gap between that 135, 49. Can't do it. Okay, so 54 and 5. Shoot, I should have just divided by 5 right away. Okay, anytime it has a 0, yeah, just divide by 5 right away. Should have done that. Those are our numbers. Hot dang. Thank you. Okay, so now that we have those numbers, we need, and it just threw me way across the page. There we go. Now we have those numbers. What we need to do is we need to actually factor this by grouping. So we have 6x squared. Let's change color. 6x squared. Now the bigger number has to be positive because we have a plus right behind. So plus 54x minus 5x minus 45. Okay, so now draw your line in the middle, factor by grouping. Now we're off to the races. Take a 6x out of both of those, and we get 6x times x plus 54 divided by 6 is going to be 9, so just 9. Now take a minus 5 out of both of these, and we get x plus 9. Perfect, because when we divide by the negative 5, we end up getting our positive. I know we're doing this right when this term and this term match, because now I can do the addition trick. I have some amount of something plus some amount of something. I have some amount of something. So we're just going to get 6x minus 5, x plus 9. Perfect. Sorry I struggle with my factoring. Clutch, by the way, on your part. And that's generically how these things go. Even the most monstrous looking ones, as long as you do your AC right and you actually get a good list of factors, you're going to be good. Okay. It's 48, so I'm going to start to line things down here. Written assignment, it's up. Written assignment 2. This, hopefully morning, but maybe afternoon, I will be putting out a Google Sheet of people that want to switch from one schedule group to the other. I will put an announcement out, so you see that. You don't need to be checking the EduCat. You will get an email from the announcements telling you that that's happened. Written assignment due Friday. Homeworks are due Saturday. We're going to keep plowing through materials so that way we can actually do that. Questions for me, math or otherwise? Okay, cool. Yeah, thank you for that.